Hey guys, welcome to this week's Wednesday independent work. It's going to be very similar to what I asked you to do last week, which was copy some notes in the workbook with me, which we'll do in a moment. So grab your workbook if you don't have it, and then practice 3 sixth grade review skills on IXL. We're still in sort of sixth grade review stuff. We'll get into 7th grade skills later on. A common question that I heard last week was, hey, do I still have to practice these skills even though like IXL says I already mastered them from last year? And the answer to that is yes, for a couple of reasons. The first reason is if you don't practice them, I can't see that you've done anything. When I look at your student progress in my IXL teacher account, it doesn't show me that you've mastered something last year. That happened with your 6th grade teacher. So on my end, it just says you didn't do anything. And the second reason you should practice it anyway is because I'm asking you to review it. I mean, I understand that you mastered it last year. I hope, right? You're supposed to. It's a 6th grade skill. You were supposed to have mastered it last year, but you also haven't used it in 6 months, 9 months, however long it's been. And so, saying, oh, well, I don't have to practice this because I mastered it last year is like if a basketball coach said, hey, I want you to go practice your 3-pointers. Go shoot 3-pointers until you've made 15 of them. And you said to your coach, no, I already got really good at 3-pointers last year, so I'm not going to do that. The coach would look at you like, what? So yeah, the whole point of it is to review. So please do that. At least do like, I don't know, 5 or 6 questions just so it shows in my IXL teacher account that you did it. I can see that you've got the mastered score and that you've got the skill fresh in your brain, please. As far as like time goes, the expectation is that you're spending about 40 minutes per class independently on Wednesdays. And so let's say this video winds up being like 12 or 13 minutes. Okay, so that means that you should be spending about 27 minutes more on like your IXL stuff. And for some students, the IXL skills that I assign will take about 27 minutes. That's great. If you're a student who can do the IXL skills that I've assigned in like 7 minutes and you've got an extra 20, then maybe you should challenge yourself. Maybe you should say, hey, you know what? That was kind of easy for me. Let me push myself, take control of my learning a little bit, and I'll practice maybe this 7th grade skill or maybe even this 8th grade skill just for a few minutes to see what it is about. Maybe I'll do well, maybe I won't, whatever. But at least I'm putting that little extra effort in to get that time. And if you're on the other end of that, where like I assign you these 3 skills and you've been messing with them for like 30 minutes and you got other stuff to do and you feel like you're not making progress, then that's okay too. I can see how long you've practiced on my screen. And so, if you feel like you're not going to be able to get there, send me an email, say, hey, Mr. Thomas, I practiced for this long. I wasn't able to get the skill up to 80 like you asked, but, I put in the effort and, I'll probably give you credit even though you didn't, get to 80 or whatever. And then maybe I might ask you to come and see me on Wednesday for some extra help or something. All right, so let's get to the notes. You copy, you got a copy, and then we'll talk about the IXL skills a little bit, and I'll let you go. Let's see here. Let me share my screen, get the doc cam going. Hopefully it works. Yes, it was a little dark. Let me turn on the light. There we go. All right, so these are the lesson 4 notes because we're going to do lesson 4 in class tomorrow and the next day. Remember that tomorrow and the next day are the first day where we have those A-B groups. So if I told you you're in the A group for your class, you got to come in the first 30 minutes of your class. And if I told you you're in the B group, then you come in the second 30 minutes of your class. You don't come for the whole hour tomorrow. And so what that means is we're going to jump right into work. As soon as you get in, we're hopping in this Desmos lesson number 4, and we're going to try to finish it in that 30 minutes. All right. So here it says a scale factor blank makes a scaled copy smaller than the original. Well, a scale factor less than 1 does that. When you have small scale factors like 1/4, 1/2, 1/3, whatever, then it's like you're making your scale copy half as big or as third as big or 1/3 as big, right? Like you're making things smaller. There's a word for this. This is called a reduction. You would say that your scale copy is a reduction in this case. All right, and then next it says a scale factor blank makes a scaled copy larger than the original, and this would be a scale factor that is greater than 1. Than 1, right? If you're multiplying all the dimensions by 2, then you're making everything twice as big. If you're multiplying everything by 1,000, then you're making things 1,000 times bigger, right? And the word for this is an enlargement. And then lastly, it says a scale factor blank makes a scaled copy the same size as the original, and that's 1, a scale factor of exactly 1, right? Because if you think about it, if you use a scale factor of 1, you're just multiplying all the sides of your original drawing by 1, and the numbers are just going to come out the same, and it'll just be the same, right? I don't think there's an actual like a special word for that. It'd be a waste of time. I don't know what you would call it. All right. So determine the scale factor between each pair of robots. So we got robot A here, and we want to find the scale factor to go from robot A to robot B. And notice robot A is 16 units tall, and robot B is 12 units tall. So we're making something smaller, right? We're going from 16 to 12. So based on the notes we just took up here, we better get a scale factor that's less than 1. Well, the way I think we should always do this is take the scale or the new, so in this case, the new robot would be the B, right? And divide it by whatever dimension corresponds in the original drawing, right? So this is like a formula here. New divided by original always gets you like the ratio between them or the scale factor. So in this case, for going from robot A to B, in this case, B is considered the new one. So we need to do B divided by A, which is going to be, what, 12 divided by 16. I like to use fractions when I'm thinking about division. I just put it into fractions because that's what fractions are. They're just numerator, top number, divided by denominator, bottom number. And then I could literally do 12 divided by 16, like in a calculator, Google, in my head, whatever. But if you just reduce it as a fraction, that's like doing the same thing. So I look at 12 and 16. I know that 4 goes into both of those. And so if I divide top and bottom by 4, I get 3/4. And so the scale factor to go from robot A to B is 3/4. And now I want to show you something super duper important that I don't know if it's covered so much in the Desmos activities or if we talked about it yet. But watch what happens now if we do the exact same thing, except it's robot B to robot A, right? So I'm just flipping it. We did robot A to B. Now I'm doing B to A. And so it's exactly the same thing, except this time B is considered the original and A is considered the new. So we're just reversing it. And now we're going from the smaller robot with a height of 12 to a bigger robot with a height of 16, right? And so the relationships here is going to be reversed. We're going to go new divided by original. And so in this case, it's A over B. And so A is the 16 and this is the 12, right? It's literally the exact same fraction or exact same division problem, just flipped. And remember, we said the word for this the other day is reciprocals. There's another word for this we'll learn later, but let's just call them reciprocals for now. All right, and so this simplifies the exact same way. I'll divide top and bottom by 4, and I get 4/3 instead of 3/4. So it's 4/3. This relationship is always true. If you know the scale factor to go from like A to B, then the scale factor to go back from B to A must just be the flip or the reciprocal of the first scale factor. That's always true. Whatever the scale factor is to go this way, flip it, and you have the scale factor to go back the other way. Because we say that, oh, robot B is a scale drawing of robot A, but that relationship goes both ways. That means that robot A must also be a scale copy of robot B. So it's just an interesting relationship that happens there. All right, so let's do robot B to robot C. Oh, well, look, robot B is 12 and robot C is 16. So if we do new divided by original, right? And so in this case, we're doing B as the original and C as the new. So that's C divided by B. It's 16 over 12. It's going to be 4/3 again, right? But we already knew that because we did that already, right? Okay, and then lastly, to go from A to C, Well, they're the same size, right? 16 to 16. We already know because of our notes up here. If you make a scale copy of something that's the same size, then the scale factor must be exactly 1. So I'm just going to put a 1 there. All right, in the summary, I just want you to make this note. If 2 drawings are scale copies of each other, right, if one drawing is a scale copy of the other, then vice versa is always automatically true. So we just say we can just say they're scale copies of each other. Then the scale factors in both directions. That means, like, you know, the scale factor to go from drawing A to B and the scale factor to go from drawing B to A are reciprocals of each other. Boom, lesson 4 notes done. All right, so let's look at IXL real quick. So I'm gonna stop this share, make my face all big for a second, but then I'm gonna screen share again. And I just wanna give you an example of how to do some of the questions you're being asked. You got 3 skills. They're similar to the same skills I asked you to do last week, because this whole idea of like ratios and fractions and division and that sort of thing is really important for like the entire first part of this class. So I just wanna make sure that this stuff's really fresh for you. So this skill is multiplying fractions. So let's see here. It says do 1/10 times 1/4. Well, multiplying fractions is the easiest of all of the operations to do with fractions, because it works exactly like you would hope it would work. You just do the top number times the top number and the bottom number times the bottom number. So 1/10, my pen works this time, times 1/4. Well, I'm just going to do 1 times 1 equals 1, and 10 times 4 equals 40. So my answer is going to be 1/40. So let's see here, let me type 1/40 into here. Should work. Boom. All right, so there's your example on multiplying fractions. So let me go ahead and close this window now. All right, and then I'm going to screen share one more time real quick. And I'm going to show this other skill that I'm going to ask you to do. I'm only going to show you 2 out of 3. This one is like figuring out equivalent fractions. It's sort of like the same skill as reducing fractions or simplifying them. And so 2/6 is equal to 1 over what? Well, the way you should think about this, let's see, I'm going to get a new color other than that yellow I just had. Let me go with green. Is when you're simplifying fractions or writing new equivalent fractions, as long as you're multiplying or dividing the number on the top of the fraction by the same number you're multiplying or dividing the number on the bottom of the fraction by, then you're going to create a new equivalent fraction, right? Things will stay equal. So let's see here. 2/6 equals 1 over blank. Well, I know that to go from 2 to 1 using multiplication or division, those are all my only options here, I'm dividing by 2, right? So that means I got to do the same thing to the bottom of the fraction in order to keep it equal. I got to divide this by 2. And 6 divided by 2 is 3. And so that means that 2/6 is the same as 1/3. Let me grab my mouse thing here. So I will click on the 3 to say that I think there's a 3 under there. Oops. And submit. Well done. Yay for me. All right, so I'll close this. And that's it. Have a good Wednesday, you guys. See you tomorrow on Friday.